So the topic what we are going to see today here is maxima and minima. So first of all, what is a maxima and a minima? Suppose I have a curve like this. Okay, so here this is the curve we have in this case. So here in this case y is equal to f of x, which is the maximum point you have here. This is the maximum point, which is the minimum point you have in this case. This is nothing but your minimum point. So by drawing a curve, you know how to find out the maximum and the minimum point, because geometrically when you represent it, it's easy for us to find out here. Okay, but that's not the case for each and every curve. We cannot just draw the curve and then find out the maximum and the minimum point actually. So here under this, you will have to find out the local maximum and local minimum, absolute maximum and absolute minimum. So what is the difference between this local maximum and absolute maximum and minimum? It's nothing but absolute maxima minima will be in a closed interval. So first we will see what is this local maximum minimum here and what is the test we use in this case. So straight away I'll go over to the second derivative test in this case. So what is the second derivative test here? The second derivative test is nothing but, first of all, if you have a curve y is equal to f of x, what you will have to do here is your step 1. What is your step 1 here? Find dy by dx. That is your first step. Okay, now what's the next step you have here? Your step 2. Step 2 is nothing but equate this to 0 and then find out what are the critical points here. So what are the critical points you get in this case? Actually here the critical points will be nothing but, suppose we obtain the critical points here, obtain the critical points in this case. So what are the critical points actually here? Suppose I say it as say C. Okay, so here we obtain the critical points. In this case we call it as say C. We have here obtain the critical points. Now what is the next one you get here? Step 3 is to find out what is your second derivative here, d squared y by dx squared. Now your step 4 is the interpretation in this case. What is the step 4 here? If your d squared y by dx squared at x is equal to c is said to be less than 0, then we call this as a local maximum. Okay, so here this is local maximum. Similarly, or else if you have your d squared y by dx squared at x is equal to c is said to be greater than 0, then we call it as a local minimum. Okay, so here this is called the second derivative test. So we will be using the second derivative test under this exercise here. Now under this absolute maxima minima here. So what is this absolute maxima minima? Absolute maxima minima will be over the closed interval a comma b here. So what is the step regarding this here? Your y is equal to, suppose f of x you have here. Now you differentiate it with respect to x, you will get dy by dx, equate it to 0 and we obtain the critical points in this case. Okay, suppose if I have x is equal to c is said to be the critical point. This critical point x is equal to c must belong to the closed interval a comma b. This is what you have here. Okay, it will belong to the closed interval a comma b in this case. So x equal to c, it belongs to the closed interval a comma b here, and you will have to find out what is your f of a, what is f of b and what is f of c. So of these, whichever is said to be maximum, that we call it as the maximum. Whichever values are said to be minimum, we call it as the absolute minimum in this case. Okay, so if it's a closed interval, we'll be going over for the absolute maxima minima condition. So with these concepts, we'll go over to exercise 6.5. Find the maximum and minimum value if any of the following functions. F of x is equal to 2x minus 1 the whole squared plus 3. So what's the first step here? You will have to differentiate it with respect to x. I am going to use only the second derivative test to find the maxima minima as well as the local maxima minima, whatever it is. Okay, so here we are going to use the second derivative test. Just now I briefed you on the second derivative test here. So differentiating it with respect to x, you will get f dash of x is equal to 2 into 2x minus 1 into differentiation of 2x minus 1. What is differentiation of 2x minus 1? That's nothing but 2. We are using the chain rule, which is equal to 4 into 2 into 2 is what? 4 into 2x minus 1. Now what is f double dash of x? F double dash of x is equal to 4 into differentiation of 2x minus 1. What is differentiation of 2x minus 1? That's nothing but 2. So you will get it to be equal to 8. Okay, so I have found the second derivative here itself. Now I'll have to find out the critical points. How do you find the critical points here? Your f dash of x is equal to 0. That is equating the first derivative to 0. So you will have it as 4 into 2x minus 1 equal to 0. So 2x minus 1 is equal to 0, which means that your x is equal to 1 by 2. This is what you have here. Okay, so here x is equal to 1 by 2 you have here. Now the minimum value, okay, how do I say that it is said to be minimum here? Your f double dash of x, what is it equal to here? It is equal to 8, which is greater than 0. So what did I tell you? If the second derivative is greater than 0, we say that the function is minimum at x is equal to 1 by 2. Because what is your critical point here? It's nothing but x equal to 1 by 2. So what is your f of x equal to here? 2 into 1 by 2 minus 1 the whole square plus 3. So here when you cancel this, 1 minus 1 is nothing but 0. 0 plus 3 is equal to 3. This is what you have here. Got it? Yes. Now B, f of x is equal to 9x squared plus 12x plus 2. This is what you have in this case. Again, I'll have to find out the maxima and minima here. So what will you have in this case? Actually, you're differentiating it with respect to x. So differentiating it with respect to x, we'll find the first derivative and the second derivative here. So when you differentiate it, what will I get here? It is 18x plus 12 is what you have here. Maybe I'll just write it clearly here. It's nothing but 18x plus 12, because differentiating 9x squared, you will have 9 into 2. That's nothing but 18x plus 12. Now here your f double dash of x is what? It is equal to 18. Got it? So when you, next step is what? To find the critical point here. So how do you find the critical point? Your f dash of x is equal to 0. So you get 18x plus 12 is equal to 0. 18x is equal to minus 12. X is equal to minus 12 by 18. So when you cancel this, 2 6 are 12 and 3 6 are 18, you will have it as minus 2 by 3. So here your f double dash of x is greater than 0 at x is equal to minus 2 by 3, because what is your f double dash of x? It is nothing but equal to 18 you get. So it is positive and greater than 0 at x is equal to minus 2 by 3. So you can say that f of x is said to be minimum. So what is the minimum value at x is equal to minus 2 by 3? So what's the minimum value at x is equal to minus 2 by 3? You will have to substitute it in the question there. So your f of minus 2 by 3 is equal to 9 into minus 2 by 3 the whole square plus 12 into minus 2 by 3 plus 2. So it's 9 into 4 by 9. So here again it gets cancelled here. It's 4 into this one, it's minus 8 plus 2. So 9 and 9 also gets cancelled here. 4 minus 8 plus 2 you get here. 6 minus 8 is nothing but equal to minus 2. So this is the minimum value at x is equal to minus 2 by 3. Got it? Third question. Find the local maxima and local minima if any of the following functions. Okay, also find the local maximum and the local minimum values as the case may be as follows. So here again I'll be using the same second derivative test in this case for all the functions. This is what we use in this case. Okay, so for the first subdivision you have here f of x is equal to x squared. Differentiating it with respect to x, you get f dash of x is equal to 2x. So here again the second derivative f double dash of x is equal to 2 you get here. So now we'll find the critical points. How do you find the critical points? F dash of x is equal to 0. So 2x is equal to 0. You get x is equal to 0 you get. Now what is your f double dash of x equal to here? F double dash of x is nothing but equal to 2, which is greater than 0 at x is equal to 0. This is what you have here. Got it? So if your second derivative is greater than 0, what can I say here? Your f of x is said to be a local minimum at x is equal to 0. This is what you have here. Okay, it is said to be a local minimum at x is equal to 0. So what is the local minimum value you get here? It's nothing but f of 0 is equal to 0 square. That's nothing but equal to 0 itself. Got it? Okay. The same way, the second subdivision. What is your second subdivision? F of x is equal to x cube minus 3x. So what are the rules you have here? The steps actually are find the first derivative. So when I find the first derivative, f dash of x is equal to differentiation of x cube. What will you have? 3x squared minus differentiation of 3x. What is that? It is equal to minus 3. Got it? Now we'll find out the critical points. To find out the critical points, I'll have to equate this to 0. F dash of x is equal to 0 you get. So 3x squared minus 3 is equal to 0, 3x squared is equal to 3, so you get x squared equal to 1, x is equal to plus or minus 1, this is what you have here, okay, x is equal to plus or minus 1. Now you have 2 points here. What are the points you get? X is equal to 1 and x is equal to minus 1. So I'll have to check for the local maximum and local minimum at both these points. At x is equal to 1, what will you get? Your f double dash of 1 is equal to 6, which is greater than 0. So if it is greater than 0, what will you say? Your f of x is a local minimum value at x is equal to 1. This is what you'll have to say here. Got it? Now the next one is what? At x is equal to minus 1. So at x is equal to minus 1, what will you have? F double dash of minus 1. What is it equal to? 6 into minus 1 is nothing but minus 6 less than 0. So what will you say here? If your second derivative is less than 0, what can I say? Your f of x is said to be a local maximum value at x is equal to minus 1. So here the local maximum value is, first we'll find out what is a maximum value. You know what is your f of x equal to here. What is your f of x equal to? It is nothing but x cube minus 3 into x. This is what you have here. So local maximum value is f of minus 1 equal to minus 1 the whole cube minus 3 into minus 1. So this will become minus 1 plus 3, which is equal to 2. Now here the local minimum value. What is the local minimum value you get? F of 1 is equal to 1 cube minus 3 into 1. So what will you have? 1 minus 3, which is equal to minus 2. Okay, so you have got the local maximum and the local minimum values. Got it? So till now we have done for algebraic functions. The next one what you are going to do here is for a trigonometric. We will see how we can find out the maximum and the minimum values. So your fourth subdivision, h of x is equal to sin x minus cos x, where your 0 less than x less than 2 pi. So what's the first step? As usual, differentiating it with respect to x. So what is your h dash of x equal to here? Differentiation of sin x is nothing but cos x. Now differentiation of cos x is what? Minus sin x. Minus of minus, what will you get here? It's nothing but plus sin x. This is what you have here, okay? Now your h double dash of x. What is your h double dash of x? Differentiating this again. So when you differentiate this, what will I get here? Differentiation of cos x is nothing but minus sin x, and differentiation of sin x is nothing but equal to cos x. Now you will have to find out the critical points here. What are the critical points you get? H dash of x is equal to 0. So you will get cos x plus sin x is equal to 0 you get here. So what is your cos x equal to here? Cos x is equal to minus sin x. Now when I bring it to the other side, you will get minus 1 is equal to sin x by cos x. So what is your tan x equal to here? Tan x is equal to minus 1. So you generally know that your tan pi by 4 is nothing but equal to 1. Okay. Here if you say it lies between 0 and 2 pi, it is given. So what are all the points I can give here? You will have to find out what is minus n. So actually if you see your tan 3 pi by 4, that is equal to minus 1 you get here. Similarly, tan 7 pi by 4, that is also equal to minus 1. Okay, I will have to stop with this because it's given in the question that it lies between 0 to 2 pi. X lies between only 0 and 2 pi. So I can only take these two values. Okay, so at x is equal to 3 pi by 4, I'll have to check the second derivative. So what will you get? H double dash of, what will I have in this case? 3 pi by 4, which is equal to minus 7 3 pi by 4 plus cos 3 pi by 4 is what you get here. Okay, it is cos 3 pi by 4. Now, what is your sin 3 pi by 4? That's nothing but equal to 1 by root 2 you get here. You already have a minus sign here, so it's minus 1 by root 2. Now here, the next one, what will you get here? It is cos 3 pi by 4. What is cos 3 pi by 4? What will you have here? It's nothing but equal to minus 1 by root 2 you get, which is equal to minus 2 by root 2. So minus 2 by root 2 means what will it's minus 2 by root 2? It's nothing but less than 0. You understood here? It's said to be less than 0. So if it is less than 0, what can I say? H of x is said to be a local maximum at x is equal to 3 by 4. Okay, so here this is what you get actually here. Okay, so here next step. So how do you get it actually here? Okay, now here the next one, at x is equal to 7 pi by 4. So what is at x is equal to 7 pi by 4? What will I get? H double dash of 7 pi by 4, which is equal to minus sin 7 pi by 4 plus cos 7 pi by 4 you get. So here what is sine of 7 pi by 4? It is equal to minus 1 by root 2 you will get. Minus of minus will give me what here? Plus. Now here cos of 7 pi by 4 is nothing but plus 1 by root 2. So you get it as 1 by root 2, which is equal to 2 by root 2 you get. That is again greater than 0. So what if it is greater than 0, what can I write here? Your h of x is said to be a local minimum at x is equal to 7 pi by 4. The fifth subdivision here, f of x is equal to x cube minus 6x square plus 9x plus 15 you get. Now differentiating this with respect to x, what will you have? F dash of x is equal to 3x square minus 12x plus what will I have here? It's nothing but 9. So again differentiating it with respect to x, what will you get? It's nothing but 6x minus 12. This is what you have here. Now if I by the second derivative test, what is that? I'll have to find the critical points. F dash of x is equal to 0 you get here. So f dash of x is equal to 0, what will you have? 3x squared minus 12x plus 9 equal to 0. Got it? So taking 3 outside, you are left with x squared minus 4x plus 3 equal to 0 you get. So when you factorize this x squared minus 4x plus 3 equal to 0, what will happen here? It will be nothing but minus 3 minus 1. This is what you have here. So 3 into x minus 3 into x minus 1 is equal to 0. So you get x is equal to 3 and x is equal to 1. So at x is equal to 3, what is the second derivative you have? Your f double dash of x is nothing but equal to 6x minus 12. So substituting it, you will have it as 6 into 3 minus 12. What will you get? 18 minus 12, which is equal to 6, which is greater than 0. So what happens here? Your f of x is nothing but a local minimum at x is equal to 3, because your second derivative is greater than 0. Now you have one more point. What is the next point you get? At x is equal to 1. So at x is equal to 1, we'll see what is the second derivative. F double dash of 1 is equal to 6 into 1 minus 12, which is equal to 6 minus 12 you get here, equal to minus 6, which is nothing but less than 0. So if it is less than 0, what did I tell you? It must be a local maximum at x is equal to 1. So f of x is said to be a local maximum at x is equal to 1 you get here. Now you will have to find out the local minimum value and local maximum value. So at what point you have got the local minimum value? At x is equal to 3. So your local minimum value is nothing but f of 3 is equal to 3 the whole cube minus 6 into 3 the whole square plus 9 into 3 plus 15. I am just substituting it in the question itself. So here when you simplify it, the answer you get is nothing but equal to 15. Similarly, your local maximum value is what? F of 1 is equal to, because the maximum value is obtained at x is equal to 1. So you will get f of 1 is equal to 1 the whole cube minus 6 into 1 the whole square plus 9 into 1 plus 15 is what you have here. 1 minus 6 plus 9 plus 15. What's the answer you get here? It is equal to 19. Got it? Yes. Now your sixth one here, again it's only an algebraic one. What is a given function here? Your g of x is equal to x by 2 plus 2 by x. X is said to be greater than 0. So differentiating it with respect to x, what is your g dash of x here? G dash of x is nothing but equal to 1 by 2. Now here when you differentiate 2 by x, you know differentiation of 1 by x. What is differentiation of 1 by x here? Differentiation of 1 by x is nothing but equal to minus 1 by x squared you get. So I'll have it as 1 by 2 minus 2 by x squared. You understood? You already have a 2 there. So the 2 is kept as it is. So it's nothing but minus 2 by x squared. This is your g dash of x. Next is what to find out the second derivative. You know that what did you get there actually? Your g dash of x is equal to, what is that you had? Your g dash is equal to 1 by 2 minus 2 by x squared is what you have here. Okay. So what is differentiation of this constant is nothing but 0. When you differentiate minus 2 by x squared, how will you differentiate this minus 2 by x squared? Minus 2 into x power minus 2. So when you differentiate it, what will I get here? D by dx of minus 2 x power minus 2. Minus 2 into minus 2 is nothing but 4 x power n minus 1. Minus 2 minus 1. What is minus 2 minus 1? That's nothing but minus 3. So what is the answer you get? It is equal to 4 by x cube. This is what you have here. It's equal to 4 by x cube. So what is g double dash of x equal to 4 by x cube. Now your g dash of x is equal to 0. It implies 1 by 2 minus 2 by x squared is equal to 0. So what will you get? 1 by 2 is equal to 2 by x squared. When you cross multiply, you will get x squared is equal to 4. So x is equal to plus or minus 2 you get. At x is equal to 2. What will you have? G double dash of 2 is equal to 4 by 8, which is equal to 1 by 2 greater than 0. So here I can say that local minimum is obtained at x is equal to 2. Now at x is equal to minus 2, we'll check the second derivative. Your g double dash of minus 2 is equal to 4 by minus 8, which is equal to minus 1 by 2. That's nothing but less than 0. So what will I say here? Your local maximum is obtained at x is equal to minus 2. You understood? Now you will have to find out the local minimum value and the local maximum value. So what is a local minimum value here? Local minimum is obtained at x is equal to 2. Substitute it in the question. What's the question you get here? Your f of x is equal to x by 2 plus 2 by x. This is what you have here. So when your x is equal to 2, you will get it as 2 by 2 plus 2 by 2, which is equal to 1 by 1 plus 1 by 1. That's nothing but equal to 2. Similarly, your local maximum value is what? F of minus 2 is equal to minus 2 by 2 plus 2 by minus 2, which is equal to minus 1 minus 1. That's nothing but equal to minus 2 itself. Got it? The working rule is more or less the same for all the questions here, but you'll have to be a little careful with the differentiation part. That's all. Okay. Now your seventh question, given g of x is equal to 1 by x squared plus 2. Differentiating it with respect to x, your g dash of x. What is your g dash of x? How will I differentiate it? I'll have to use the u by v formula. So what is your u by v formula here? D by dx of u by v is equal to v into du by dx minus u into dv by dx divided by, what will I have here? It's nothing but v squared. So it is x squared plus 2 into differentiation of 1 is nothing but 0. Minus 1 into differentiation of the denominator is nothing but 2x divided by x squared plus 2 the whole squared. So this becomes 0. So you are left only with minus 2x divided by x squared plus 2 the whole squared. So this is your g dash of x. So g double dash of x is equal to, by using u by v formula, you will have it as x squared plus 2 the whole squared into minus 2 plus, okay, why I write plus here even though you have a minus sign in the formula? Because you have minus 2x here, so minus of minus will be nothing but plus 2x into differentiation of the denominator. 2 into x squared plus 2 into differentiation of this will give you what? 2x divided by x squared plus 2 the whole power 4. Okay, so here you can take x squared plus 2 common here. So you are left with minus 2 into x squared plus 2 plus 8x squared divided by x squared plus 2 the whole power 4. So here if you see it gets cancelled, you are left with x squared plus 2 the whole cube you get here. Now it is, when you multiply it, what will I get? Minus 2x squared minus 4 plus 8x squared is what you get here, divided by x squared plus 2 the whole cube is what you have here. Got it? Now what will happen in this case? Actually here you are left with 6x squared minus 4, okay, divided by, what will I have here? It's 6x squared minus 4 divided by x squared plus 2 the whole cube is what you have here. Okay, so here we'll just substitute the limit in this case. So here your g dash of x is equal to 0, that is equating it to 0. So when I equate it to 0, what will I have here? Actually here it's nothing but equal to minus 2x divided by x squared plus 2 the whole cube, okay, which is equal to 0. Now when you cross multiply, you will have it as minus 2x equal to 0. So your x is nothing but equal to 0. So I've just substituted it in the second derivative here. So when I substitute it, you will have it as g double dash of 0 is equal to 0 minus 4 divided by 0 plus 2 the whole cube, which is equal to minus 4 by 8. That's nothing but equal to minus 1 by 2 less than 0. So what can I write here? Local maximum is obtained at x is equal to 0. And what is a local maximum value actually here? It's nothing but g of 0 is equal to 1 by 0 plus 2. That's nothing but equal to 1 by 2. Got it? Yes. Now here your 8th subdivision. What's your 8th subdivision? F of x is equal to x into square root of 1 minus x. So differentiating it with respect to x, what will you have? F dash of x is equal to, I'll have to apply the uv formula. So when you apply the uv formula, what will you have? X into differentiation of this one, I'll have, okay, 1 by 2 into 1 minus x the whole power minus 1 by 2. So what's the formula we use here? D by dx of x power n is equal to n x power n minus 1. This is the formula we use here. 1 minus x the whole power minus 1 by 2 into differentiation of 1 minus x. What is differentiation of 1 minus x? It's nothing but minus 1. Okay, 0 minus 1, so it's nothing but minus 1 plus square root of 1 minus x into differentiation of x. What is differentiation of x here? It's nothing but equal to 1. Okay, so here x into minus 1 is nothing but minus x divided by 2. Here this comes to the denominator, so you're left with square root of 1 minus x plus root of 1 minus x. You can simplify this because when you cross multiply here, what will I get? Minus x root into root is nothing but equal to 2 into 1 minus x divided by 2 into root of 1 minus x. This is what we write in the next step. So I told you in the next step, what is that we have written here? Minus x plus 2 into 1 minus x divided by 2 into root of 1 minus x. So when you multiply here, it's minus x plus 2 minus 2x you get here. So it is 2 minus 3x divided by 2 into root of 1 minus x. This is what you have here. Got it? Now you will have to find out the second derivative. So how do you differentiate it with respect to x? Again by using the u by v formula. What is your f double dash of x equal to here? 2 into root of 1 minus x into differentiation of the numerator. So what is differentiation of the numerator? 0 minus 3x. So what will I get here? It's nothing but minus 3 minus of 2 minus 3x into differentiation of the denominator. So what is differentiation of the denominator? 2 into 1 by 2 into 1 minus x the whole power minus 1 by 2 into differentiation of 1 minus x. That's nothing but minus 1 divided by, when I square this, what will I get here? 2 squared is nothing but 4 into root of 1 minus x the whole square. That's nothing but into 4 into 1 minus x. This is what you have here. Okay, so I will just simplify it here. Minus 6 into square root of 1 minus x you have here. Minus into minus is nothing but plus. So here if you see 2 and 2 gets cancelled, it is 2 minus 3x divided by square root of 1 minus x, because 1 minus x the whole power minus 1 by 2 you get, divided by 4 into 1 minus x. Got it? Now you just cross multiply here. Minus 6 into 1 minus x plus 2 minus 3x divided by, this comes to the denominator, so it is 4 into square root of 1 minus x into 1 minus x is what you have here. Now multiply it, it's minus 6 plus 6x plus 2 minus 3x divided by 4 into root of 1 minus x into 1 minus x. So what will you have? It's minus 4 plus 3x divided by 4 into root of 1 minus x into 1 minus x. Now equate it to 0. F dash of x is equal to 0. So f dash of x is equal to 0 means the first derivative is equal to 0. So you have it as 2 minus 3x divided by 2 into square root of 1 minus x is equal to 0. Cross multiplying here, you will have it as 2 minus 3x is equal to 0. So what will you get? 2 equal to 3x, which means that your x is equal to 2 by 3. Got it? Now at x is equal to 2 by 3, what will you have? F double dash of 2 by 3 is equal to minus 4 plus 3 into 2 by 3 divided by 4 into square root of 1 minus 2 by 3 into 1 minus 2 by 3. Then simplifying, first of all I need to know whether it is positive or negative. Okay, so you need not write the exact value here. So what will you get? Minus 4 plus 2 is nothing but minus 2 divided by 4 into square root of 1 by 3 into 1 by 3. Obviously it's nothing but negative, that is it is said to be less than 0. So if it is less than 0, what can I say here? In this case, your local maximum is obtained at x is equal to 2 by 3. So local maximum is obtained at x is equal to 2 by 3. What is your local maximum value? F of 2 by 3 is equal to, you know what is your f of x equal to here? X into square root of 1 minus x. This is what you have here. So f of 2 by 3 is equal to 2 by 3 into square root of 1 minus 2 by 3, which is equal to 2 by 3 into square root of 1 by 3. So you will have it as 2 by 3 root 3. This is your local maximum value. Got it? Yes. The fourth question, prove that the following functions do not have maxima or minima. So till now we found out the local maximum and the local minimum value. Here under the fourth question, what you are going to do here is, we'll have to check whether, why we have to say that they do not have a maxima or a minima function here. So what is that you have? First step, first question, f of x is equal to e power x. So it is differentiating with respect to x. You will get f dash of x is equal to e power x you will get here. When I equate it to 0, you will get e power x is equal to 0. So when do you get e power x is equal to 0? Only when your e power minus infinity only will be equal to 0. But this is not applicable in this case. In other words, what can I say here? So there does not exist an x belonging to the real numbers such that your f dash of x is equal to 0, because you cannot find out a value of x which satisfies or which gives you whether the maxima condition or the minima condition. So I say that it does not have a maxima or minima. You understood? Yes. Now here your b, g of x is equal to log x. Now differentiating it with respect to x, you get g dash of x is equal to 1 by x. So here when I equate this to 0, you will get 1 by x is equal to 0. So when do you get 1 by x to be 0? Only when your x is equal to infinity. So here again I cannot find out a value of x. Okay, so here such that your g dash of x is equal to 0, and that is the reason we say that we cannot find out the maxima or minima. So how do I say here? There does not exist any x belonging to R such that your g dash of x is equal to 0. Hence g does not have a maxima or minima. H of x is equal to x cube plus x squared plus x plus 1. Again I will have to say why this function does not have a maxima or minima here. So find out your h dash of x. What is it equal to? 3x squared plus 2x plus 1. H dash of x is equal to 0. You have it as 3x squared plus 2x plus 1 is equal to 0. So x is equal to minus 2 plus or minus square root of b squared is what? 4 minus 12 divided by 6. So what's the formula we use here? X is equal to minus b plus or minus square root of b squared minus 4ac divided by 2a. Okay, so here this is the formula we have used here. So here it's minus 2 plus or minus square root of minus 8 divided by 6. So here this root of minus 8, how can I write this root of minus 8 as? Actually here I can write it as I, because that can be written as 4 into 2, that minus sign it becomes I there. What happens to this root 4? Root 4 is nothing but 2 into root 2. So when you divide it, you will have it as minus I plus or minus root 2I divided by 3. This is what you have here. So what is this? Actually it's a complex number. So again it does not belong to the set of all real numbers. That is, in other words, I can say that there does not exist a x belonging to R such that your h dash of x is equal to 0. Thus h does not have maxima or minima. Okay, so till the fourth question we found out the maxima minima or the local maxima minima we found out. From the fifth question onwards, we are going to find out the absolute maxima and absolute minimum. So I told you the absolute maxima and absolute minimum, what is the difference? It will be defined in the closed interval there. Okay, so when you see the question, you will understand it more. So the fifth question, find the absolute maximum values and the absolute minimum value of the following functions in the given intervals. So your f of x is equal to x cube, where x belongs to the closed interval minus 2 comma 2. Now differentiate it with respect to x. What will you get? Your f dash of x is equal to 3x squared. Okay, see the first step. Second step is what? Equate it to 0 and find out the critical points. F dash of x is equal to 0. You will get 3x squared is equal to 0. In other words, your x is equal to 0 and it belongs to, okay, I'll have to check whether it belongs to this closed interval minus 2 comma 2. So when you have minus 2, minus 1, 0, 1 and 2. So your 0 is also included in this interval. That is why I say that x is equal to 0. It belongs to minus 2 comma plus 2 in the closed interval. You understood? Now you will have to find out at all the 3 points, you will have to find out what is your f of x there. So x is equal to 0. What is your f of 0 equal to? 0 cube, which is equal to 0. At x is equal to minus 2, what will you get? F of minus 2 is equal to minus 2 the whole cube, which is equal to minus 8. So at x is equal to 2, your f of 2 is equal to 2 the whole cube, which is equal to 8. So what will you say? Your absolute maximum value is said to be 8, because what is the highest value you get here? 8. It is obtained at x is equal to 2. Now if you see what is the absolute minimum value, that's nothing but minus 8. So it is obtained at what point? Actually here at the point x is equal to minus 2. You understood? Okay. Now here your B subdivision. What's your B subdivision? F of x is equal to sin x plus cos x, where your x belongs to the closed interval 0, pi. This is what you have here. Now differentiating it with respect to x. What is your f dash of x equal to here? Cos x minus sin x. So you will get f dash of x equal to 0. So f dash of x is equal to 0 means you will have it as cos x minus sin x is equal to 0. So as usual you will have cos x is equal to sin x, you will get. When you bring it to the other side, you will have it as 1 equal to sin x by cos x. What will you have? Tan x is equal to 1. So already you know that tan pi by 4 is nothing but equal to 1 here. Okay, so tan pi by 4 is equal to 1. It means that your pi by 4, it lies in the closed interval, okay, 0 to pi. Okay, it lies between 0 and pi. So I can say that it lies in the closed interval here 0 to pi. Now we'll start with x is equal to 0. So at x is equal to 0, your f of 0, what is your f of x equal to here? F of x is equal to sin x plus cos x you have here. So it is sin 0 plus cos 0. What is this equal to here? It is equal to 1. At x is equal to pi by 4, f of pi by 4 is equal to sin pi by 4 plus cos pi by 4. What will you have? 1 by root 2 plus 1 by root 2, which is equal to 2 by root 2. That's nothing but equal to root 2. Now the next one is what? At x is equal to pi. What will you get? F of pi is equal to sin pi plus cos pi. That's nothing but 0 minus 1, which is equal to minus 1. So now you can check these three values I have ticked here. Which is the least value? This is the least value. Which is the highest value? This is the highest value, because root of 2 is nothing but 1.414, you know. So I can say that absolute maximum is root 2 at x is equal to pi by 4, and absolute minimum is minus 1 at x is equal to pi. You understood? So here it's a very easy one. There's absolute maxima and minima. Only thing is what? You will have to first check if it lies between the interval, then find out the least and the maximum value and then write it. That's all. Okay. Now your C subdivision here, f of x is equal to 4x minus 1 by 2 x squared. X belongs to minus 2 comma 9 by 2. Now here differentiating it with respect to x, what will you get? F dash of x is equal to, differentiation of this will give you what? 4 minus 1 by 2 into differentiation of this is nothing but 2x. 2 and 2 gets cancelled. So you are left with 4 minus x. Now I'll have to equate it to 0. So 4 minus x is equal to 0 means you will get x is equal to 4. So 4 belongs to minus 2 comma 9 by 2. That is, it lies between minus 2 and 9 by 2. Because what is your 9 by 2? It's nothing but 4.5. So before that only lies 4. So I can say that it lies between minus 2 comma 9 by 2. So at x is equal to minus 2. So at x is equal to minus 2, what is your f of x equal to here? You know, your f of x is nothing but equal to 4x minus 1 by 2 into x squared. So when you substitute it, 4 into minus 2 minus 1 by 2 into minus 2 the whole square. So you will have it as minus 8. So it's plus 4 by 2 you will get here. So it gets cancelled. Minus 8 minus 2, that's nothing but equal to minus 10. Now here the next one is what? At x is equal, see at all the 3 points, at the end points plus this point also, at the critical point also. So at x is equal to 4. What will you get? F of 4 is equal to 4 into 4 minus 1 by 2 into 4 the whole square. So it is 16 minus 8, that's nothing but equal to 8. The next one is what? At x is equal to 9 by 2. F of 9 by 2 is equal to 4 into 9 by 2. So 4 into 9 by 2 minus 1 by 2 into 9 by 2 the whole square. So you will get it as 36 by 2, 81 by 4, 81 by 8. So when you take the LCM, it's 8 here. 36 into what will I get here? 4. It's 144 minus 81, which is nothing but equal to 63 by 8. So here we'll see what is maximum value here. Here in this case 63 by 8 it will be equal to 7 point something only I will have here, but above that you have 8, which is the least value you get here. It's nothing but equal to minus 10. So absolute maximum is 8 at x is equal to 4 and absolute minimum is minus 10 at x is equal to minus 2. Got it? Yes. Now here your 7th question. Okay. Now find both maximum value and minimum value of 3x power 4 minus 8x cube plus 12x squared minus 48x plus 25 on the interval 0, 3, closed interval 0, 3. So you may think what to find out here, local maxima minima, or what is it here actually here, in this case what local maxima minima or the absolute maxima minima. So check for the interval in this case. What is the interval here actually? It's nothing but a closed interval. Okay. So f of x is equal to 3x power 4 minus 8x cube plus 12x squared minus 48x plus 25. So differentiating it with respect to x, what will you have? F dash of x is equal to 12x cube minus 24x squared plus 24x minus 48 you get, which is equal to 12 into x cube minus 2x squared plus 2x minus what will you get here? It's nothing but equal to 4. Okay. Now I'll have to find out the critical points. So to find out the critical points, we'll just simplify it here. Here when I take these two terms, I can take x squared common. X squared into x minus 2 plus 2 into x minus 2 you get here. Okay. So it is 12 into x minus 2 is common to both the terms. So we have written x minus 2 into x squared plus 2. So f dash of x is equal to 0. We have already found out f dash of x. 2 into x minus 2 into x squared plus 2 is equal to 0 you get. So you will have x is equal to 2. Okay, and the other one you will get x squared is equal to minus 2 you will get. This x is equal to 2, it lies in the closed interval 0, 3. Am I right here? But this it does not belong to. So this part is not applicable here, or it is not possible in this case. So I can take only x is equal to 2 as the critical point here. You understood? Because it does not belong to the closed interval 0, 3. So here what are the points you will have to find out? The end points are 0 and 3 and the critical point is 2. So I will have to find out the values at all the 3 points. So at x is equal to 0, your f of 0 is equal to, substituting it, 0 minus 0 plus 0 minus 0 plus 25, which is equal to 25 you get. Now at x is equal to 2, your f of 2 is equal to 3 into 2 power 4 minus 8 into 2 cube plus 12 into 2 the whole squared minus 48 into 2 plus 25. So what will you get? 48 minus 64. Okay, 8 into 8 it's 64, 12 into 4 48, 96 plus 25. Simplifying it you get it as minus 39. What's the next one? At x is equal to 3. What is at x is equal to 3 is what? F of 3 is equal to 3 into 3 power 4 minus 8 into 3 cube plus 12 into 3 squared minus 48 into 3 plus what will you get here? 25. So 3 power 4 is what? 81. 81 into 3 is 243. Here you will get 27 into 8 is 216. 12 into 9 is 108. Here if you see it's minus 144 plus 25. So what's the answer you get here? It's nothing but 16. So what is absolute maximum is nothing but 25 at x is equal to 0, and absolute minimum is nothing but minus 39 at x is equal to 2. So here this is what you get here. What's the maximum value you get here? The maximum value is nothing but 25. The minimum value is nothing but minus 39. Okay. So I think this is more easier for you, the absolute. Once again I am telling you, if they don't mention the absolute maxima or minima, check for the interval there. If the interval is a closed interval, it's enough if you find out the absolute maximum and absolute minimum. Got it? Yes. Now here your 8th question. At what points in the interval 0, 2 pi? So check this one here, because concerning your trigonometric functions, within this limit only you will have to take the critical points, because for trigonometric functions the critical points can be going on actually here, but you will have to restrict it within this limit. Does the function sin 2x attain its maximum value? This is what is given here. So we'll start here. Your f of x is equal to sin 2x. Now differentiating it with respect to x, your f dash of x is equal to 2 into cos 2x you get here. So f dash of x is equal to 0. What is that you get? 2 cos 2x is equal to 0, which implies your cos 2x is equal to 0 you get. So cos 2x is equal to 0 means what will I get here? Your 2x is equal to, you know that cos pi by 2 is nothing but equal to 0. Similarly, cos 3 pi by 2 is also 0. 5 pi by 2 is also 0. 7 pi by 2 is also 0. I cannot take more than this. I cannot take, what is it here actually here? 9 pi by 2. The reason why I can't take 9 pi by 2, it will be outside the interval 2 pi. You understood? So I stop till 7 pi by 2. Now what is your x equal to here? Pi by 4. 3 pi by 4, 5 pi by 4 and 7 pi by 4. That is bringing this 2 here, you will have these here. So these are the critical points you here. Got it? So here these critical points, they lie in the interval here 0 to 2 pi. So here we will have to check the maximum and the minimum here. So at x is equal to 0, you know what is your f of x equal to here? What's your f of x equal to? Sin x. So at x is equal to 0, f of x 0 is nothing but equal to 0. That sin 0 is equal to 0. How I generally started 0 comma 2 pi means, okay, I will start with the lower limit in between all the other and then you will start with 2 pi here. Okay. So here at x is equal to pi by 4, what will you get here? Your f of, sorry, it's sin 2x you get, so it is sin 0. Now here it is f of pi by 4 which is equal to sin 2 pi by 4 you get. So here it gets cancelled, sin pi by 2, you know sin pi by 2 is nothing but equal to 1. Okay. Next is what? At x is equal to 3 pi by 4, you will get f of 3 pi by 4 is equal to sin 2 into 3 pi by 4. So again if you see it gets cancelled. So it is sine of 3 pi by 2 you get. So you know what is sine of 3 pi by 2? What is sine of 3 pi by 2? Sine of pi plus what will I get here? It's nothing but pi by 2. This is what you get here. So what is the sine of pi plus pi by 2? What will I have? It is equal to, what will I get in this case actually here? It is equal to minus cos. So here, yeah. So here this is equal to minus 1. Okay, this is what you have here. Okay, it is equal to minus 1 is what you have in this case. The next one is what? At x is equal to 5 pi by 4. So what is it? X is equal to 5 pi by 4. What will I get? F of 5 pi by 4. Again it is 2 into 5 pi by 4. So here if you see it's nothing but it gets cancelled. So you are left with sin 5 pi by 2 you will get. So what is sine of 5 pi by 2? That's nothing but equal to 1. Okay, so here this is what you have here. Okay, so here in this case you will just have it as minus sine pi by 2 you will get. That is how you get here. So minus sine by 2, that's why I say that it is equal to 1, because I would have given you in the formula itself what is sine of pi plus theta. Okay, so what is sine of pi plus theta equal to there? That's nothing but equal to minus sine theta I would have given you. So it is equal to minus sine theta. We have it as minus sine pi by 2 which is equal to minus 1. The same thing here also, sine 5 pi by 2 you have got here. So when I write it as sine 5 pi by 2 also, the same way you will have to split it. The answer will be equal to 1 is what you get here. Now here at x is equal to 7 pi by 4. So at x is equal to 7 pi by 4, what will you get? F of 7 pi by 4 which is equal to sine of 2 into 7 pi by 4 you get. It gets cancelled. Sine of 7 pi by 2. So what is the sine of 7 pi by 2? Again it will be nothing but sine of pi plus 3 pi by 2 I can write here. Sine of pi plus 3 pi by 2. So what will be sine of pi plus 3 pi by 2? It's nothing but minus sine 3 pi by 2. What is that equal to here? That's nothing but equal to minus 1. Sorry, it will be equal to sine 3 by pi by 2 you will get here. That's nothing but equal to minus 1 is what you get here. Now the last one, at x is equal to 2 pi. So at x is equal to 2 pi, what will I get? Your f of 2 pi is equal to sine 4 pi. So what is sine 4 pi here? Sine 4 pi is nothing but equal to 0. So what is the absolute maximum here? Absolute maximum is nothing but 1 at x is equal to pi by 4 and 5 pi by 4, because you get it here and also at the point, because they have asked us to check only for the maximum value here. So I check only the maximum value in this case. You understood? Okay, so you will have to be a little clear with what is sine of pi plus pi by 2, what is sine of pi, that part alone you will have to be a little careful here, and then write what is the maximum and the minimum value in this case. Okay, now here the 9th question. What is the maximum value of the function sin x plus cos x? Okay, they have asked us only for the maximum value of the function sin x plus cos x. Now here in this case, now just check the interval is not given to us. Okay, no interval is given to us here. So what is that you will have to do here? In this case, if the interval is not given to you, what happens actually, the critical points will go on. Okay, so I'll just tell you how you get it here. F of x is equal to sin x plus cos x. Differentiating it with respect to x, your f dash of x is equal to cos x minus sin x. This is what you have here. So your f dash of x is equal to 0 means cos x minus sin x is equal to 0. Your cos x is equal to sin x, so you get tan x is equal to 1. Okay, so you have it as x is equal to pi by 4, not only pi by 4, 5 pi by 4 is also equal to 1, 7 pi by 4 is also equal to 1, 9 pi by 4 is also equal to 1, etc. Because the interval is not mentioned to this. So what test I will be using in this case? Actually here I will be using the second derivative test. I cannot go by the absolute maxima minima condition. Now I hope you understand the difference between both. Earlier it's not only the interval which is important, it must be a closed interval, only then you can apply the absolute maxima minima there. Here in this case it's not a closed interval, the interval is not mentioned itself, I will have to go only by the second derivative test in this case. Okay, so here your f double dash of x is what? Minus sin x minus cos x you get. So at x is equal to pi by 4, your f double dash of pi by 4 is equal to minus sin pi by 4 minus cos pi by 4. So it is minus 1 by root 2 minus 1 by root 2, which is equal to minus 2 by root 2, which is equal to minus root 2, that's nothing but less than 0. So by the second derivative test, what will you say? At x is equal to pi by 4, the function is said to be maximum. So you can find out the maximum value. What's the maximum value? F of pi by 4, which is equal to 1 by root 2 plus 1 by root 2, which is equal to 2 by root 2. What is 2 by root 2 equal to here? That's nothing but equal to root 2. Okay. The 10th question, find the maximum value of 2x cube minus 4x plus 107 in the interval 1, 3. Find the maximum value of the same function in minus 3, minus 1, closed interval. Now you yourself can guess, okay, but hereafter it will be only a mixed one. So it's a closed interval which is given. So what I'll have to use here? The test absolute maximum and absolute minimum. This is what I'll have to use in this case, not the second derivative test. I hope you're clear with that concept here, where to use the second derivative and where to use the absolute maximum and absolute minimum. So in this case, they have given us for two intervals. So I'll just take it as case 1 and case 2. Okay, so first case is in the interval, closed interval 1, 3. I'll have to find out the maximum and minimum. Second is in the interval minus 3, minus 1. Okay, closed interval. So differentiating it with respect to x, f dash of x is equal to 6x squared minus 24. So f dash of x is equal to 0 means your 6x squared minus 24 is equal to 0. So 6x squared equal to 24 you get. So what is your x squared equal to here? X squared is nothing but equal to plus 4. So what is your x equal to here? Plus or minus 2. So x is equal to 2 or x is equal to minus 2. Okay. Now you take the first case here. What is the first case here? 1, 3. So of these two critical points, which critical point lies in the interval? Only 2 lies in the interval 1, 3. So I say that x is equal to 2. It belongs to the closed interval 1, 3. So what is your f of 1 equal to? 2 into 1 cube minus 24 into 1 plus 107, which is equal to 85. Got it? Now we will find out f of 2. What is f of 2? 2 into 2 the whole cube minus 24 into 2 plus 107, which is equal to 16 minus 48 plus 107, that's equal to 75. Okay. F of 3. What is f of 3? 2 into 3 the whole cube minus 24 into 3 plus 107. So it is 27 into 2 54, 24 into 3 72 plus 107, which is equal to 89. Okay. So here what will I write here? The absolute maximum is obtained at x is equal to 3. Now the absolute minimum is obtained is, what is absolute minimum in this case? Actually here this one, it is nothing but 75 at x is equal to 2 here. Okay, once again a reminder here, when we take like this, if 2 belongs to that closed interval, you will have 3 points where you will have to find out 2, 1 and 3. Always I start with the lower limit here 1, then in between the critical point, then the upper limit. That is how I generally take here. Got it? Okay. Now that is next is your case 2. Okay, so here your case 2 you get here. So what is a case 2 interval here? Case 2 interval is nothing but -3 comma -1. So you have got two critical points here. What was the other critical point you got? X is equal to -2. X is equal to -2, does it lie in the interval here? Yes, it lies in this interval. But the other critical point, X is equal to 2, it does not lie in the interval. I hope you understand what I mean by saying it lies in the interval. It's -3, -2 and -1 I can say here. Okay, so in between it lies here. So -2 it lies, it belongs to -3 comma -1. Now we'll find out what are the what's the absolute maximum and the absolute minimum value in this case. So it is f of -2. What is f of -2? 2 in, I'll have to substitute in the question, children. 2 into -2 the whole cube minus 24 into -2 plus 107. -2 the whole cube is what? -8. So it's -16 plus 48 plus 107, which is equal to 139. Next is what? F of -3. 2 into -3 the whole cube minus 24 into -3 plus 107. So here if you say it's -54 plus 72 plus 107, which is equal to 125. Next is what? F of -1. 2 into -1 the whole cube minus 24 into -1 plus 107. -2 plus 24 plus 107, that's equal to 129. So they have asked us for the absolute maximum value. So what's the maximum value you get for the second case here? 139 at x is equal to -2. If at all they ask for the absolute minimum value also, you can write what is the absolute minimum value. But in this question it's not asked here. So anyhow, I'll just write it here. What's the absolute minimum value? What will I get here? It's 125 at x is equal to -3. Got it? Yes.